Hello, in this video I want to show you two things. How to enter this formula to calculate this probability of observing more than 30 potholes in a section of a highway of 5 miles. So I want to show you how to enter this formula and how you obtain this probability. In the second part, I'm going to show you how to create the probability distribution or the Poisson probability distribution in Excel for this problem, the mishandling of bags by delta. So in other words, I want to show you how to create this table. All right, let me exit the full screen in PowerPoint, and let's go to Excel. So in Excel, I already, in a blank worksheet, I just put example 2 and what I want to calculate and the value of lambda. So in here, in a cell beyond this text, then you enter the formula by first typing equal. Then if you look at the formula right here, is 1 minus the probability that the number of potholes is less or equal than 30. So we're going to enter that formula. So I want to type 1 minus, then the Poisson probability. So I want to type Poisson, and you see right away, you see this option, Poisson.dist. Select that. And then it's asking you the value of x and the mean for the distribution and whether it's cumulative. In this case, we want to find the cumulative probability distribution. So in this case, I will type 30, comma, space. The mean, in this case, is 25. And you can see the example to see how we obtain 25. And here, if you notice, you have two choices. True for a cumulative probability distribution and false for a probability mass function. In other words, the exact probability. So in this case, we want this term, which is the cumulative probability. That's the probability of x equals to 0, plus the probability of x equals to 1, plus the probability of x equals to 2, all the way to the probability of x equals to 30. So Excel can do this in a single calculation. So I'm going to click on true and then close the parentheses. So then you type enter, press the enter key, and it gives you the probability. This is the number that you see on slide 71. All right, so that's for that example 2. For example 3, we want to calculate the Poisson probability distribution where the mean is 2.19. Now, if you remember, the sample space of a Poisson random variable starts at 0, but it could go to infinity. So the question is, well, how many numbers can we enter on this list? So let's look at the table that I created. And if you notice, I have 12 values for the random variable. So in this case, I want to type 0, because there could be 0 mishandled bags. And then we put the cursor on the lower right corner of the cell. You see the little cross. Then I press, after I see the cross, I press the control key, and then you see the little cross up to the right of that original cross. Then you click and drag it down until you see the number 12. So that now we have the possible values of x from 0 to 12. Then we want to calculate the exact probabilities that in, like for example, in the first cell, that x is equal to 0. In other words, 0 bags are mishandled. To do that, then I type the formula by starting with typing equal, then type Poisson, and then you select Poisson distribution. As soon as you type PO, then this option comes up on Excel. So click on Poisson distribution. And in here, X is going to be the first cell here, which is B7, and that's 0. So I click on that. So now Excel knows that it's going to use this number in this cell. Then the mean, as we have it up here, is 2.19. And because I want the the exact probability, I click on false, because this probability must function is referring to calculating the exact probability. So click on that and then close the parenthesis and type enter. So press the enter key. So then Excel calculates that first Poisson probability. So now to calculate the rest of the probabilities, just click on the get the cursor or place the cursor on the lower right corner of the cell. Once you see the black cross, then drag it down until the last value of X, which is 12. All right, so there is the Poisson probability distribution for a parameter lambda of 2.19, where we know that in this problem, lambda is the average number of bags mishandled by this airline. All right, so we'll stop the recording right here, and I'll post it so that you know how to create this probability distribution.